Somewhere between Mars and Jupiter, there's a chunk of metal floating in space worth more than, well, literally everything on Earth, combined, times 100,000. Oh, you think I'm exaggerating? Cute. This isn't science fiction. NASA is literally sending a spacecraft there right now. And when I tell you what's about to happen, you'll understand why every billionaire on Earth is either sweating bullets or secretly planning their space mining empire. Welcome to the story of 16 Psyche, the asteroid that could either make everyone on Earth a billionaire or completely destroy the concept of money as we know it. Buckle up. This is going to get weird.
Let me paint you a picture. You wake up tomorrow morning, check your phone, probably before you even get out of bed because, let's be honest, we're all addicts, and you see the most insane headline you've ever read. Breaking. Every human on Earth now worth $1.3 billion thanks to space rock. Your first thought? Finally, I can afford guacamole at Chipotle without feeling guilty. Your second thought? Wait, this has to be fake news. But here's the thing. It's not fake. Well, not entirely. There's an actual asteroid floating out there in space right now, as we speak, that contains enough precious metals to make every single person on Earth a billionaire. Not a millionaire, a billionaire. Its name is 16 Psyche. And before you ask, no, it's not named after your ex, although the damage it could do to the global economy might be comparable. This isn't some far-off science fiction fantasy. NASA has literally launched a spacecraft that's heading there right now. It left Earth on October 13th, 2023, Friday the 13th, because apparently NASA likes to tempt fate, and it's currently hurtling through space at 24,000 miles per hour toward our cosmic lottery ticket. Oh, and did I mention that every government on Earth is quietly freaking out about this? That billionaires are secretly funding space mining companies faster than you can say wealth inequality? That economists are having actual nightmares about what happens when we crack open this celestial piggy bank? Buckle up, space cowboys and cowgirls. We're about to dive deep into the story of the most valuable object in the known universe, why it might destroy everything we know about money, and why the race to claim it might spark the first true space gold rush. And trust me, by the end of this video, you'll never look at your wallet the same way again.
Let me take you back to March 17th, 1852. While America was busy with the California gold rush, oh, the irony, an Italian astronomer named Annibale de Gasparis was doing what astronomers did back then, staring at the sky through a telescope and trying not to fall asleep. Gasparis was working at the Naples Observatory, and he'd already discovered 9 asteroids. This was his hobby. Other people collected stamps. This madman collected space rocks. That night, he spotted a faint point of light moving against the background stars. He probably said in Italian, "Another space potato for my collection." He named it Psyche, after the Greek goddess of the soul. Why? Because it was the 16th asteroid ever discovered, and apparently by number 16, you run out of good names. It's like naming your 16th cat. At some point, you just start picking random words from mythology. What should we call this one, Annabelle? I don't know. How about, Psyche? What does that have to do with a space rock? Look, it's 2 a.m. and I'm tired. Psyche it is. For the next 100 years, Psyche was just another boring asteroid, number 16 in a catalog that would eventually grow to over 1 million. Nobody cared. It was like being the 16th person to climb Mount Everest. Sure, impressive, but nobody's making a movie about you. But then, in the 1960s, something interesting happened. Astronomers started using a new technique called radar astronomy. Basically, they bounced radio waves off asteroids and analyzed what came back. It's like cosmic sonar, but cooler, because space. When they aimed their equipment at Psyche, they got a weird result. This thing was reflecting radar signals like crazy, way more than a regular rock should. Scientists are, that's odd. Also scientists, let's poke it with more science. By the 1980s, they'd figured out something mind-blowing. Psyche wasn't made of rock. It was made of metal. Now, finding metal in space isn't that unusual. Iron meteorites fall to Earth all the time. I mean, not all the time. Don't start wearing helmets to bed. But often enough that we have plenty of samples. But Psyche was different. This wasn't just a chunk of iron. This was a massive ball of metal 140 miles in diameter, just casually orbiting between Mars and Jupiter like it owned the place. To put that in perspective, Psyche is about as wide as Massachusetts. Imagine Massachusetts, but instead of aggressive drivers and Dunkin' Donuts, it's solid metal worth more than, well, we'll get to that. The real excitement started in the early 2000s when scientists started using spectroscopic analysis. That's a fancy way of saying they looked at what colors of light bounced off Psyche and used that to figure out what it's made of. It's like identifying what's in someone's lunch by the smell, except the lunch is 230 million miles away and the smell is electromagnetic radiation. Totally the same thing. The results were staggering. Psyche appeared to be made of iron, boring but useful, nickel, your phone battery says hello, gold, now we're talking, platinum, oh my, rhodium, worth $14,000 per ounce by the way, and potentially massive amounts of other rare metals. But here's where it gets really crazy. In 2017, a study led by Arizona State University calculated the value of Psyche based on its metal content. The number they came up with? $10 billion. That's 10,000 quadrillion dollars. Let me help you understand how stupidly big that number is. If you started counting to 10 quadrillion right now, one number per second, no breaks, no sleep, no bathroom breaks, which, let's face it, you'd need, it would take you 317 million years to finish. The dinosaurs went extinct 65 million years ago. You'd have to count through their entire existence, evolution, and extinction almost 5 times. But wait, there's more, because apparently the universe wasn't done showing off. Astronomers started wondering, why is there a giant ball of metal just floating in space? The leading theory is absolutely wild. They think Psyche might be the exposed core of a planet that never quite made it. A protoplanet, if you want to get technical.
Here's what probably happened, and this is where it gets Game of Thrones levels of dramatic. About 4.5 billion years ago, when the solar system was young and reckless, Psyche was trying to become a planet. It had formed a metal core, started building rocky layers on top, was probably feeling pretty good about itself. Then wham, something huge smashed into it. Maybe another protoplanet, maybe a massive asteroid. This collision was so violent that it literally stripped away all the rocky material, leaving just the metal core exposed. It's the cosmic equivalent of someone stealing your sandwich and leaving just the pickle, except the pickle is worth more than Earth's entire economy. So, actually, a pretty good deal. This makes Psyche unique in our solar system. We can't study Earth's core directly. It's 3,000 miles down and about 10,000 degrees Fahrenheit. That's slightly outside OSHA's safety guidelines. But Psyche? That's a planetary core just floating out there, completely exposed, like the universe's most valuable anatomy lesson. NASA scientist Lindy Elkins-Tanton, who leads the Psyche mission, once said, "We're going to visit a world made of metal. Not rock, not ice, but metal." If that doesn't sound like the plot of a heavy metal album cover, I don't know what does.
So NASA, being NASA,
heard about a giant ball of metal worth 10,000 quadrillion dollars and thought, you know what, let's go poke it with a robot. The Psyche mission was first proposed in 2011. Some scientist, probably hopped up on coffee and ambition, submitted a proposal to NASA's Discovery program. This is basically NASA's version of Shark Tank, but for space missions. Hi sharks, I'm seeking $450 million to send a robot to a metal asteroid that might be worth more than everything on Earth. I'm out. Mark Cuban, probably. But here's the thing. NASA said yes. In 2017, they officially selected the Psyche mission. Why? Because scientists gonna science. That's why. The mission has several official objectives. 1. Determine his Psyche is actually a planetary core. 2. Figure out how old it is. 3. Understand what it's made of. 4. Study its geology. Or, metallology? Is that a word? But let's be real. They also want to know if this thing is actually worth 10,000 quadrillion dollars, or if we've all been getting excited about a cosmic paperweight. Building the spacecraft took years. This isn't like assembling IKEA furniture, although I'm sure there were moments where someone was holding apart wondering, where the hell does this go? The spacecraft itself is a marvel. Let me break down this beautiful robot for you. Size. About the size of a singles tennis court when fully deployed. Weight. 2,747 kilograms. That's about as heavy as 2 Toyota Corollas. Power. 2 giant solar panels that generate 21 kilowatts at Earth, but only 2.3 kilowatts out at Psyche. It's basically going from a gaming PC's power consumption to a hairdryer. Hope they brought batteries. Propulsion system. Here's where it gets cool. The Psyche spacecraft uses something called solar electric propulsion, or ion propulsion for those of us who've watched Star Trek. Instead of burning chemical fuel like a regular rocket, it uses electricity to accelerate xenon ions to incredibly high speeds. The thrust is tiny, about the same force as the weight of a AA battery in your hand, but it can run for years. Think of it this way. Chemical rockets are like drag racers, massive acceleration for a short time. Ion propulsion is like a Prius, slow acceleration, but it'll run forever on a tank of gas. Except the gas is xenon and the tank is space. The spacecraft carries 1,085 kilograms of xenon. That's over a ton of noble gas, which sounds like something you'd order at a pretentious restaurant. Yes, I'll have the Asteroid probe with a side of noble gas, and can you make sure the xenon is locally sourced? The instruments. This is where the real magic happens. First, we have the multispectral imager. This camera can see in wavelengths your Instagram filter could never dream of. It'll map every crater, ridge, and feature on Psyche's surface. Fun fact, the imager has filters that can detect specific minerals. It's like having glasses that let you see what everything is made of. Imagine walking through a jewelry store with those bad boys. Next up, the gamma ray and neutron spectrometer. This instrument is basically a cosmic metal detector on steroids. When cosmic rays hit Psyche's surface, they create gamma rays and neutrons that are characteristic of specific elements.
It's like each element has its own fingerprint, and this instrument is the detective dusting for prints. Aha! Gold was here, and it brought its friend, platinum. Then there's the magnetometer. This measures magnetic fields, which is crucial because if Psyche really is a planetary core, it might still have a magnetic field frozen into it from when it was molten billions of years ago. It's like checking if your frozen pizza was ever actually hot, but for planets. And finally, my personal favorite, the Deep Space Optical Communications Experiment. NASA is testing laser communication. Instead of using radio waves like every spacecraft since forever, they're going to shoot lasers back at Earth. This could increase data transmission rates by 10 to 100 times. We're literally going to be getting Instagram quality photos from an asteroid instead of potato quality. The future is now, people. The launch. October 13th, 2023.
Friday the 13th. Someone at NASA either doesn't believe in superstitions or has a wicked sense of humor. The launch vehicle was a SpaceX Falcon Heavy, because of course it was. Nothing says the future like a billionaire's rocket company launching a government probe to a quadrillion-dollar asteroid. The Falcon Heavy is essentially 3 Falcon 9 rockets strapped together, which sounds like something a 5-year-old would design, but it works. It can lift 64 metric tons to low Earth orbit, though for Psyche it only needed to send about 2.7 tons on an escape trajectory. It's like using a monster truck to deliver a pizza. Sure, it's overkill, but it's awesome overkill. The launch went perfectly. The side boosters landed back at Cape Canaveral in perfect synchronization because SpaceX likes to show off. The center core was expended, making the ultimate sacrifice for science. The journey. This is where patience comes in. The spacecraft isn't taking a direct route to Psyche. That would require an insane amount of fuel. Instead, it's taking the scenic route, using what's called a Mars gravity assist. Here's the timeline. 2023 to 2026. The spacecraft slowly spirals outward from Earth, gradually building up speed. It's like slowly winding up for the universe's longest pitch. May 2026, Mars flyby. The spacecraft will zip past Mars at just 500 kilometers altitude, using the planet's gravity to slingshot itself toward the asteroid belt. Thanks for the boost, Mars. See you never. 2026 to 2029, 3 more years of cruising through the darkness. The spacecraft will be running on ion propulsion almost continuously, slowly but surely approaching its target. During this time, the mission team will be doing what they do best, worrying about everything that could go wrong. Solar panel degradation? Check. Micrometeorite impacts? Check. Alien abduction? Okay, probably not, but someone's thought about it. August 29, arrival at Psyche. But here's the thing, arrival doesn't mean landing. Oh no, that would be too simple. Instead, the spacecraft will go into orbit around Psyche. And this is where it gets tricky. We actually don't know Psyche's exact mass, which means we don't know its exact gravity pull. It's like trying to park a car when you don't know how strong the parking brake is. The spacecraft will start in a high orbit, about 700 kilometers above the surface, and slowly spiral down over 21 months. It's the cosmic equivalent of a nervous person slowly entering a cold pool. The orbits are labeled with letters because scientists love their alphabets. Orbit A, 700 kilometers altitude, the let's not get too close orbit. Orbit B, 290 kilometers altitude, the okay, seems safe orbit. Orbit C, 170 kilometers altitude, the getting interesting orbit. And Orbit D, 85 kilometers altitude, the holy crap we're close orbit. At the closest approach, the spacecraft will be just 85 kilometers from a ball of metal worth 10,000 quadrillion. That's like hovering a drone 85 meters above Fort Knox if Fort Knox was the size of Massachusetts and floating in space.
All right, let's talk about everyone's favorite subject that they pretend to understand. Economics. Specifically, what happens when you introduce 10,000 quadrillion dollars into an economy worth $100 trillion. First, let me blow your mind with some context. The entire global economy, every business, every bank account, every hidden mattress stash, every Bitcoin wallet, every dollar in circulation, adds up to roughly $100 trillion. Psyche, if the estimates are correct, is worth 100,000 times that. That's not a rounding error. That's not, oh, we were off by a bit. That's, we need to invent new numbers to describe this territory. Let me paint a picture of what would happen if we somehow, magically, brought all of Psyche's metals to Earth tomorrow. And I mean magically, because the logistics alone would take centuries, but humor me here. Ding! Your Uber asteroid has arrived. That'll be, how do you charge for delivering $1 quadrillion? Hour 1, the announcement. Every major news network breaks the story simultaneously. CNN, Fox News, BBC, they all forget their political differences because, holy crap, space gold. The headlines write themselves. Asteroid successfully delivered to Earth. Everyone on Earth now a billionaire. Economics hate this one simple trick. Hour 2 through 6, the celebration. Stock markets go insane. Gold prices, well, they don't crash because trading is immediately suspended. You can't trade something when infinite supply just showed up. Champagne sales skyrocket. Everyone's calling their boss to quit. Twitter crashes from everyone tweeting, "We're rich!" Your annoying crypto bro who won't shut up about blockchain suddenly seems a lot less annoying. At least his fake money wasn't made worthless by space rocks. Day 2. The smart people speak up. Economists, who've been frantically doing math all night fueled by coffee and existential dread, start appearing on news shows. Well, actually, they adjust their glasses. If everyone has $1 billion, then nobody has $1 billion. The public, what? It's simple supply and demand. If gold is no longer scarce, it's no longer valuable. The public, but, space gold. Week 1, the denial phase. Governments try to control the narrative. The Federal Reserve issues a statement that basically amounts to, "Please remain calm while we figure out what the hell to do." The price of everything starts creeping up. That $5 coffee, now $50. That $1,000 iPhone, try $10,000. People start realizing that being a billionaire doesn't mean much when a loaf of bread costs $1 million. Congratulations, you're technically rich. Also, you can't afford lunch. Enjoy your theoretical wealth. Week 2 through 4, the collapse. Every gold mine on Earth shuts down. Why mine gold when there's literally a Massachusetts-sized chunk of it in wherever? Countries whose economies depend on mining precious metals watch their GDP evaporate. South Africa, 11% of the world's gold. Economic apocalypse. Peru, gold is their #1 export. Switches to exporting alpaca memes. Australia's mining sector. Crikey, we're screwed. Russia's gold reserves. Turned into space dust. Month 2, the new reality. The entire concept of money has to be rebuilt. Fiat currency, which was already basically imaginary, becomes even more imaginary. Some countries try to switch to cryptocurrency. Others try to back their currency with other resources: water, energy, land, rare Pokemon cards, whatever isn't made worthless by Psyche. The United States dollar is now backed by the full faith and credit of, our really nice national parks. Yellowstone is pretty cool, right? Months 3 through 6, the adaptation. Humans are remarkably adaptable. We survived ice ages, plagues, and the finale of Game of Thrones. We can survive economic apocalypse. New economic systems emerge. Energy becomes the new gold standard. You can't asteroid mine electricity yet. Intellectual property becomes insanely valuable. Can't mine ideas from space. Services over goods economy accelerates. Robots can't asteroid mine a good haircut. But here's the really interesting part, and why economists are fascinated rather than terrified. This has happened before, just smaller. The Spanish price revolution, 1500s. When Spain brought back massive amounts of gold and silver from the Americas, it caused massive inflation across Europe. Prices increased 600% over 150 years.
Hey, Europe, we brought you gold from the New World. Great. Why is everything suddenly expensive? Oops. The California Gold Rush. 1849, the discovery of gold in California added $2 billion in 1850s dollars to the global economy. It caused inflation, sure, but it also funded the Industrial Revolution. The aluminum crash, 1880s. Here's my favorite example. In the 1550s, aluminum was more valuable than gold. Napoleon III had aluminum cutlery for his most honored guests, while lesser guests had to make do with gold. Then, in 1886, someone figured out how to extract aluminum cheaply using electricity. The price crashed 96% in 10 years. Did the world end? No. We just started making airplanes and soda cans out of what used to be the most precious metal on Earth. Your Coke can was once worth more than gold. Let that sink in next time you're recycling. But Psyche is different. It's not just about adding more gold to the economy. It's about fundamentally breaking the scarcity model that all economics is based on. The scarcity problem. Economics 101. Value comes from scarcity. Things are worth what people will pay, and people will pay more for rare things. Water in the desert? Valuable. Water in the ocean? Not so much. Gold on Earth? Valuable. Gold when there's a Massachusetts-sized chunk of it? But here's the mind-bending part. What if scarcity ended? What if Psyche is just the beginning? What if we start mining multiple asteroids? What if all raw materials become essentially free? This is called post-scarcity economics, and it's based on Star Trek. No money, no want, everyone just works for the betterment of humanity. Yeah, right. Have you met humanity? We can't even agree on pizza toppings, and you think we're going to share infinite resources fairly? But let's explore what a post-scarcity economy might actually look like. The experience economy. If physical goods become essentially free, what has value? Experiences, creativity, human connection. That concert ticket? Still valuable. You can't mine live music from space. That master chef's meal? Still valuable. Asteroids are notably bad at cooking. That therapist appointment? Probably more valuable. We'll all need therapy after the economy collapses. The reputation economy. When everyone has unlimited resources, social capital becomes the new currency. Your followers, your reputation, your network. That's your wealth. So basically, influencers inherit the earth. I'm sure that won't go wrong at all. But there's a plot twist that nobody talks about.
So, let's say we all agree that mining Psyche is a great idea. How exactly do you mine something that's 230 million miles away, has no atmosphere, temperatures ranging from negative 280 degrees Fahrenheit to 800 degrees Fahrenheit, and, oh yeah, is the size of Massachusetts? Spoiler alert, it's really, really hard. Let me walk you through the absolutely insane engineering challenges that make this feel like trying to perform surgery while riding a roller coaster in the dark while wearing oven mitts. Challenge number 1, getting there with mining equipment. The Psyche spacecraft weighs about 2.7 tons, and it's basically just cameras and sensors. An actual mining operation would need drilling equipment, probably 10 plus tons, processing facilities, 50 plus tons, storage containers, 20 plus tons, return vehicle, 30 plus tons, crew habitat, if manned, 100 plus tons. So, we need to send about 200 tons of equipment to an asteroid. Current launch costs are about $2,000 per kilogram to low Earth orbit. That's $400 million just to get your equipment to space, not even to the asteroid. It's like paying $400 million for an Uber to the airport, and you haven't even bought your ticket yet. Challenge number 2, zero gravity mining. On Earth, when you drill into something, gravity keeps you pressed against it. In space, Newton's third law becomes your worst enemy. For every action, there's an equal and opposite reaction. Push a drill into an asteroid, and the asteroid pushes you away. Imagine trying to drill a hole while floating in a pool, except the pool is space, and if you float away too far, you die. Solutions being considered. Harpoon anchors, literally shooting yourself to the asteroid. Claw grippers, like a massive space crab. Nets, catching an asteroid like a cosmic Pokemon. How did you mine the asteroid? We harpooned it like cosmic whalers. That's the most metal thing I've ever heard. Challenge number 3, processing in space. Even if you can mine the ore, you can't just ship raw asteroid back to Earth. It would be like shipping entire mountains to get a few pounds of gold. You need to process it in space, which means separating metals from rock without water, which we use on Earth, refining metals to useful purity without massive furnaces, and storing processed materials without warehouses. Current ideas include solar furnaces using concentrated sunlight to melt metals, magnetic separation, pulling iron and nickel out with magnets, and 3D printing components directly from asteroid material. Yeah, we're talking about 3D printing in space using space materials. The future is weird. Challenge number 4, transportation back to Earth. Let's say you've successfully mined and processed 100 tons of platinum. Congratulations! Now, how do you get it home? Option 1, direct return. Build a spacecraft on the asteroid and fly it back. Problems? Expensive, dangerous, and you're literally piloting a $1 trillion cargo through space. Option 2, mass drive. Build a railgun on the asteroid that shoots packages of metal toward Earth. Problems? Accuracy, missing Earth would be embarrassing, and catching high-speed space packages. Honey, did you order something from space? No. Why? Because there's a platinum meteorite in our backyard? Option 3, space elevator. Build a cable from Earth to space and just lower the materials down. Problems? We can't even build a regular elevator that doesn't break down. And you want to build one to space? Challenge number 5, the economics of space mining. Here's the dirty secret nobody talks about. Even if Psyche is worth 10,000 quadrillion dollars, mining it might cost 11,000 quadrillion dollars. Current estimates for a basic asteroid mining mission. Development costs 10 to 50 billion, launch costs 1 to 5 billion, operations 100 million per year, return mission 5 to 10 billion. Total 20 to 70 billion dollars for one mission that might return $1 trillion in materials. That's a good return, but it assumes everything goes perfectly. In space, nothing goes perfectly. Remember Mars Climate Orbiter? It crashed because someone forgot to convert imperial to metric. Cost? $327 million. Oops! Good news, we found the asteroid. Bad news, we forgot to account for solar wind and it's now heading toward Jupiter. Well, at least Jupiter will be rich. The company's actually trying this. Despite the challenges, several companies have tried or are trying to make asteroid mining happen. Planetary Resources, 2010 to 2018. Founded by Peter Diamandis and Eric Anderson, backed by Google executives and James Cameron. Plan? Start with water-rich asteroids, then move to metals. Result? Went bankrupt in 2018, assets bought by consensus.
Turns out, investors want returns this century, not next century. Deep Space Industries, 2013 to 2019. Plan, build a fleet of small prospecting spacecraft. Result, acquired by Bradford Space, now focuses on satellite propulsion. Translation, mining asteroids is hard. Let's just make spacecraft parts instead. Asteroid Mining Corporation, 2016 to present. UK-based, still operational. Plan, start with asteroid prospecting missions by 2027. Status, still raising funds, still optimistic. SpaceX, not officially, but come on. Elon Musk says SpaceX is about making life multiplanetary. But Starship can carry 150 tons to orbit. That's not for tourists, that's for equipment. The breakthrough technologies we need. For asteroid mining to actually work, we need some serious technological breakthroughs. 1. Fusion rockets. Current rockets are too slow and use too much fuel. Fusion rockets could cut travel time by 75% and use asteroid water as fuel. Status? Always 20 years away for the last 50 years. 2. Self-replicating robots. Send one robot that builds more robots using asteroid materials. Status? we can barely make robots that vacuum properly. 3. Closed-loop life support. For human miners, we need systems that recycle everything. Status: the ISS still needs regular supply runs. 4. Artificial gravity. Long-term zero gravity destroys human bodies. Status: requires massive rotating habitats we can't build yet. So, basically, we need Star Trek technology to mine asteroids, but we're still stuck with smartphones that die after a day. Cool. Cool, cool, cool.
Now let's talk about the elephant in the room. Or should I say, the elephant in the vacuum of space. Who owns Psyche? According to the Outer Space Treaty in 1967, signed when computers were the size of rooms and the most advanced phone was a rotary dial, no nation can claim sovereignty over celestial bodies. But here's the thing. That treaty was written when asteroid mining was pure science fiction. It's like having laws about the internet written by people who'd never seen a computer. No nation shall claim the moon or other celestial bodies. Cool. What if a corporation claims it? A what now? What if an individual claims it? Why would anyone want a space rock? Oh, you sweet summer children of 1967. The current legal framework, or lack thereof. The Outer Space Treaty says, space is the province of all mankind. Whatever that means. No weapons of mass destruction in space. Regular weapons are apparently fine. No sovereignty claims, but mining isn't mentioned. Countries are responsible for their company's space activities. Good luck enforcing that. The Moon Treaty of 1979 tried to clarify things by saying, space resources are the common heritage of mankind. Guess how many spacefaring nations signed it? None. 0. Zilch. The US, Russia, China, they all looked at it and said, yeah, no. The new space laws. Seeing the legal vacuum, pun intended, countries started making their own rules. United States, 2015. The Commercial Space Launch Competitiveness Act explicitly allows U.S. citizens to possess, own, transport, use, and sell asteroid resources. Translation: finders keepers, losers weepers, but in space. Luxembourg, 2017. Passed a law allowing space mining companies to keep what they extract. Also offers funding and regulatory framework for space mining companies. Luxembourg is, we missed the boat on regular colonization, but space colonization, we're getting in early. UAE, 2020, created a space resources law allowing private ownership of space resources. Because when you've got oil money, why not buy some space laws? Japan, 2021, passed legislation allowing Japanese companies to extract and use space resources. Godzilla was unavailable for comment. China's silent strategy. While everyone else is passing laws, China is building capabilities. They've landed on the far side of the moon, first ever. Brought back lunar samples, first in 45 years. Announced plans for asteroid mining by 2030. And built a space station because the ISS wouldn't let them join. China is, you guys keep arguing about laws, we'll just be over here practicing. Their strategy is brilliant. Don't talk about it, just do it. By the time everyone figures out the legal framework, they'll already be mining. The military problem. Here's the scary part nobody wants to talk about. The technology to move asteroids for mining is the same technology you'd need to weaponize them. Think about it. Redirect an asteroid for mining? Good. Redirect an asteroid at your enemy? Bad. But it's the same technology. A 10-meter asteroid hitting Earth at typical speeds would release energy equivalent to a nuclear bomb. And we're talking about learning to move asteroids that are miles wide.
It's not a weapon, it's a mining tool. That mining tool is heading straight for Beijing. Oops. The US Space Force, yes, that's a real thing now, has already stated that protecting commercial space assets is part of their mission. Translation, if you mess with our space mines, we'll do space stuff to you. The alliance problem. Traditional military alliances don't cover space. NATO Article 5, an attack on one is an attack on all, only applies to Earth and airspace. So if China attacks a US mining operation on Psyche, does NATO respond? Nobody knows. New alliances are forming. The Artemis Accords, a US-led moon and asteroid mining agreement, China-Russia lunar partnership, European Space Agency trying to stay neutral but failing. It's like the Cold War, but in space. The Cooler War? The Absolute Zero War? The corporate Wild West. While governments argue, corporations are preparing for a gold rush. SpaceX plus NASA equals Team America, Blue Origin plus US Space Force equals Team Bezos, China National Space Administration plus state-owned enterprises equals Team China, Roscosmos plus Russian oligarchs equals we're still relevant. It's like the Olympics, but instead of medals, they're competing for literal astronomical wealth. The first asteroid claim. Here's how it'll probably go down. 2029, NASA's Psyche mission confirms massive metal deposits. 2030, every nation announces their own Psyche mission. 2031, China announces they're already on the way. 2032, SpaceX announces a crewed mission. 2033, Russia announces they were there first but didn't tell anyone. 2034, first hardware lands on Psyche. 2035, multiple nations' companies arrive simultaneously. 2036, the lawyers get involved. 2037 to 2050, court battles while robots mine anyway. The Psyche war scenarios. Scenario 1, the peaceful division. Everyone agrees to divide Psyche equally. Likelihood? Have you met humans? Scenario 2, the corporate takeover. First company there claims it all, backed by their nation's military. Likelihood? Depressingly high. Scenario 3, the Space U. A new international body is created to manage asteroid resources. Likelihood? Medium, but it'll be toothless. Scenario 4, the Wild West. No rules, everyone mines what they can, conflicts resolved by who has the biggest space guns. Likelihood? This is basically human history, so yeah. My money's on Scenario 4, but with more lawyers and less cowboy hats. Although, space cowboy hats would be cool. So let's zoom out and look at the big picture. We're talking about fundamentally changing the economic structure of human civilization. This isn't just about money, it's about what kind of species we become. The end of resource wars. Most wars in human history have been about resources: land, water, oil, minerals. We've killed each other over dirt since we figured out how to sharpen sticks. But what if resources were infinite? No more fighting over oil. Asteroids have hydrocarbons. No more water wars. Asteroids have ice. No more rare Earth conflicts. Asteroids have, well, everything. Of course, we'd probably just find new things to fight about. My space rock is better than your space rock. Humans gonna human. The environmental renaissance. If we can mine space instead of Earth, we could literally save the planet. No more strip mining, no more deforestation for resources, no more deep-sea drilling, no more destroying ecosystems for metals. We could let Earth heal while we plunder space. It's like moving your party from your living room to your garage. Your house stays nice while you make a mess elsewhere. Mining Psyche alone could provide enough metal for thousands of years without touching Earth. The expansion imperative. Here's the thing. Once we can mine asteroids, staying on Earth becomes optional. With unlimited resources, we could build massive space stations, O'Neill cylinders with millions of people, Mars colonies. Terraforming becomes economically feasible. Generation ships. Why not visit other stars? Dyson spheres. Harness all of the sun's energy. Honey, I'm thinking about moving. Where? New York? Tokyo? Actually, I was thinking Jupiter's moon, Europa? Is the rent cheaper? The evolution of humanity. This is where it gets philosophical. Are we still human if we live in space? After a few generations in low gravity, humans would physically change. Longer limbs, less gravity resistance. Weaker bones, don't need them in space. Larger eyes, artificial lighting. Radiation resistance, natural selection is harsh. We could literally become different species. Homo sapiens on Earth, Homo spatialis in space. But here's the dark side. Who gets to benefit from asteroid mining? If SpaceX mines Psyche, does Elon Musk become the world's first trillionaire? Quadrillionaire? If China mines it, does the Chinese government control the global economy? If corporations mine it, do they become more powerful than nations? President Musk of the Tesla SpaceX corporate state welcomes you to Earth. Please have your visiting visa ready. The gap between rich and poor could become the gap between earthbound and spacefaring. The philosophical crisis. When resources are unlimited, what gives life meaning? If everyone can have everything, what's the point of working? If machines can do everything, what's the point of humans? If we can live forever, medical advances from space resources, what's the point of procreation? We might solve all of humanity's material problems only to discover we've created entirely new existential ones. We solved poverty, hunger, and disease. Great. Now what? I don't know. Netflix? Let me give you my honest prediction of what happens. 2029, Psyche mission confirms value. 2030 to 2035, space mining gold rush begins. 2035 to 2040, first successful asteroid mining operation. 2040 to 2075, economic transformation period, rough times. 2075 to 2100, a post-scarcity economy emerges. 2100 plus, humanity becomes truly spacefaring. Your grandchildren will live in a world where gold is as common as aluminum. Your great-grandchildren might live in space. Your great-great-grandchildren might not even be recognizably human. All because of a metal potato floating between Mars and Jupiter.
So there you have it, 16 Psyche. A chunk of metal that nobody cared about for 170 years that might completely reshape human civilization. It could make everyone rich, but also make money meaningless, end resource scarcity, but create new problems, launch humanity into space, but fragment our species, save Earth's environment, but militarize space, advance technology by centuries, but cause economic chaos. The spacecraft is already on its way. In 6 years, we'll know what we're really dealing with. In 20 years, someone will try to mine it. In 50 years, your life will be unrecognizable. Or maybe it's just a big space rock and we're all getting excited over nothing. But where's the fun in that? The real question isn't whether we can mine Psyche. We can. The technology will get there. The question is, are we ready for what happens when we do? Because ready or not, the future is coming at us at 24,000 miles per hour, and it's made of solid metal worth more than everything we've ever dreamed of. Thanks for spending this hour exploring the economics of space rocks with me. If this kept you watching, consider subscribing. If it didn't, you probably stopped watching 45 minutes ago, so you're not hearing this anyway. Next week, we're talking about something even crazier. Yeah, we're going there. Until then, remember, you're living in the last generation that thinks gold is valuable. Your grandkids will laugh at your jewelry while wearing asteroid platinum like it's plastic. Sweet dreams, future space peasants.